Hello, algebra students. Mr. Lawrence here with a flipped lesson, and this really should be review. Although seventh graders, you're going to want to pay extra close attention, get lots of practice with it, because I know for a fact you guys, this is not a review for you. You should have learned it last year, but your teacher didn't focus on it, and that's okay. We'll try to close that hole in your learning right now. All right. Well, scientific notation. Before we get to it, I'm gonna ask you a couple questions, and then we'll talk about what it's used for. All right. What happens when I multiply by 10, 100, or 1,000? Okay, well, the safe answer that'll just make Mr. Lawrence very angry is that you'll say, well, it gets bigger. Well, no fooling. Come on. What happens when I multiply 3 times 10? Well, I get 30. Okay, but something just happened there. Something that you may not be realizing. What happens if I multiply 4 by 10? Well, of course, I get 40. But let's pick a number between 3 and 4, like 3.712. What happens when I multiply that by 10? Well, don't I get 37 and 12 hundredths? I mean, think about it. 3 is 3 and 712 thousandths is between 3 and 4. If I multiply it by 10, just like 3 and 4, the answer has to end up being between 3 and 4. The the answer to the question is what happens when I multiply by 10? Well, the decimal point moves one place. See that? Yeah, it was here for the 3, and then it moves behind the 0. Okay, so when I multiply by 10, the decimal point moves one place to the right. What do you think will happen if I multiply by 100? Well, we'll take 3 times 100, and you're going to get 300. Wasn't the decimal point originally here? Right? There's a decimal point right here. When we don't see it, we assume it's at the end of the number. So we move it 1, 2 places. So when I multiply by 10, the decimal point moves one place to the right. When I multiply by 100, it moves 2 places to the right. 1,000, 3 places to the right. Hey, look at this. 1 0, 2 zeros, 3 zeros. Coincidence? I think not. Okay. Now what happens when I divide by 10, 100, or 1,000? Well, probably a pretty similar idea. I mean, let's start real easy. Let's take a number like 400 or 40 and let's divide it by 10. Well, doesn't it end up being 4? Now, if you've been paying any attention to the decimal point, you knew it was here, and so then it scoopied there, right? So it moved one place to the left. If I have a number like, say, 6.81, and I divide by 10, well, I'm going to end up with 0.681. Oops, got an extra 1 in there. Sorry about that. So when I divide by 10, the decimal point moves one place to the left. If I divide by 100, it's going to move 2 places left. 1,000, 3 places left, etc. The number of zeros tells me how many places it's going to move. Okay. Now, why do we use scientific notation? Scientific notation is used to express really, really large numbers, like distances in space. I mean, the Earth is 93 million miles from the sun. It's a very large number, but in terms of space distances, it's pretty tiny. Okay. Um, Also, the number of cells in your body. It's an extremely large number. Scientists might use scientific notation as a form of shorthand so they don't have to deal with it. Oops, something just happened there. But it looks like we're still recording, so everything's okay, I hope. All right. All right. Also, very, very tiny numbers that are still positive. Uh, it's difficult to deal with this. And reading that is a pain. So a scientist might call it 1.23, and then let me see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the negative 11. All right, and we'll talk about that in a minute. But I'd rather deal with this number than this number. And this is the scientific notation form of the number. That's all it is. Numerically, they're the same thing. Okay. What you need to know, to be in scientific notation, you need to have one non-zero digit followed by the decimal point. Okay, so for example, this is not scientific notation because there are two non-zero digits followed by the decimal point. So that is not scientific notation. This would be scientific notation. Okay, even though these two numbers might be equal to each other, this one is scientific notation. Now I know some of you are thinking, how could they be equal to each other? Well, you'll see as we get better at this. All right, second of all, multiply by 10 to some power. You notice here I had 10 to the negative 11th, here I have 10 to the 4th. To be in scientific notation, you're going to have one non-zero digit, the decimal point. You might have some numbers after the decimal point, and then you're going to have multiplied by 10 to a power. So let's see these four examples here. We'll call them A, B, C, and D. And I'm going to convert those to scientific notation. By the way, they're in standard notation right now. And the first thing I'm going to do is I'm going to locate my decimal point. It's right there. But I want it to be here. So I want my answer to be 3 and 52 hundredths something times 10 to a power. Well, what power am I going to multiply it by? Well, let's see here. The easy way to do this would be to figure out how many times I'd have to multiply by 10 to get the decimal point there. And actually, I'm dividing by 10, but I'm not trying to confuse you. So 1, 2, 3, 4, 5, 6, 7, 10 to the 7th power. All I did was count the spaces, then I moved the decimal point. It's like I divided by 10 to the 7th power. Well, let's see, 10 to the first is obviously 10, and 10 to the second is 100, right? So 10 to the 7th is the same as 1, 2, 3, 4, 5, 6, 7, right? Okay, so it's 10 million. So I just divided that number by 10 million. That's how I get this tiny decimal, 3.52, compared to 35,200,000. Okay, now you'll hear this number, like especially in contracts and sports. Like I'll see somebody signed for $1.5 million. All right, you'll see like 3.52 times 10 to the 7. All right, anyway, let's convert B to scientific notation. My decimal point is here. I want it where the comma is. I want my decimal number to be this. So 1, 2, 3. I'm going to multiply by 10 to the third power, which is 1,000. And you can check this. If I multiply 1 and 254 thousandths by 1,000, I will get 1,254. Okay, so there's those two numbers, scientific notation. Now this one, here's the decimal point right now, but I want it to be there. I want my decimal to look like 4.51 times 10 to a power. But here I'm actually multiplying this decimal, right, to get it to be larger. So I'm going to multiply by 1, 2, 3, 4, but I use the negative fourth because to go backwards I want to divide. I want it to be a tiny number. As you know, the negative exponent means use the stairs. So this would be the same as 4.51 over 10 to the fourth power, which is 1, 2, 3, 4, 10,000, right? And when I convert that to standard notation, that's going to become quite small, like that. Okay, this is the scientific notation answer. This is what's going on mathematically to tie in the connection with the negative exponent. Okay, this one here, we're going to want 1.27. How many tens do I have to multiply it by to get that decimal point between the 1 and the 2? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to multiply by 10 to the negative ninth power. All right, hopefully you're catching on here. Hopefully you've noticed that when we have a very large number like this, we have a positive exponent. But when we have a very small number, still positive but smaller than 1, we end up with a negative exponent. And that will always be the case. All right, now to go the other way is just as easy. In some ways, it's easier. I'm multiplying by 10 to the fifth. So my decimal point is going to move 5 places. So it's going to go 1, 2, 3, 4, 5. And there you go, 320,000. If you prefer, you can actually show the movement. I'll do this one first, the 4.81. I've got to move it 2, so I can go 1, 2. Then I'm going to say, well, you need to rewrite the number so it's pretty. Okay. Here we've got a negative exponent. I'm going to need that decimal point to go the other direction, so I end up with a number smaller than 1. So I'm going to get 1, 2, 3, fill in the zeros. Then if you're going to do it this way, I'm going to insist you rewrite the number 0.00681. Now somebody's going, wait a minute, didn't he say there had to be one non-zero number, then the decimal point? That's to be in scientific notation. I'm going from scientific notation. This is standard notation, so I don't need to do that. Okay. Now, if you're good at these, so what am I doing on time? If you're good at these, you may not need to show all the little scoopies. You might be able to go 184 and then count backwards, of course. This would be 1, so I'm going to go 2, 3, 4, 5, 6, 7. Put my decimal point in, put a 0, and there is standard notation. And you can check 1, 2, 3, 4, 5, 6, 7. There it is. All right. So that is scientific notation in a nutshell. We're going to get some practice with it. And that'll be it for tonight. All right. Mr. Lawrence signing off. Good night, everybody.